Hello students, my name is Professor Muhammad Asim and we are doing ADMath. ADMath for IGCSE students which have syllabus code 0606 and for CIE O level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we did exercise 16.2 till question number 9. Today we will do remaining two questions of this exercise, question number 10 and 11. But before I start exercise 16.2, first I would suggest all those students who are watching my lecture first time, kindly go to my playlist. There is a folder, name is ADMath. Watch previous lectures of this exercise. After watching previous lectures, you will able to do remaining questions. So let's start question number 10. A particle starts from rest at a fixed point O and moves in a straight line towards a point A. The velocity v meters per second of the particle t seconds after leaving O is given by v is equals to 8 minus 8 e minus 2t. Part A. Find the acceleration of the particle when t is equals to ln 5. So in order to find acceleration, we have to differentiate velocity. We will get acceleration. Derivative of 8 is 0 minus 8. Derivative of e minus 2t is minus 2t into derivative of minus 2t, that is minus 2. Hence acceleration is 16 minus plus 8 to the 16 upon e power 2. Now find the acceleration at t is equals to ln 5, which is equals to 16 upon e 2 into t, which is ln 5. The rule of logarithm is power can be right after the log. 16 upon e ln 5 square, which is 25. Ln and e cancel. 16 upon 25 and 16 upon 25 is 0.64 meters. Move to part B. Given that the particle reaches at A when t is equals to 2, find the distance OA. Give your answer correct to three significant figures. Very easy. We have velocity v is equals to 8 minus 8 e minus 2t. Now find the value of distance. We must differentiate velocity. The limit must be from 0 to 2. Why? Because at O the value of t is 0 and 8a the value of t is 2, which is given in the question. You can see. So 8 minus 8 e minus 2t dt. S is equals to 8 integration is 8t, limit 0 to 2 minus 8 e minus 2t integration is e power minus 2t, but upon the derivative of the function, which is minus 2, and limit from 0 to 2. So s is equals to 8, apply the limit 2 minus 0, minus minus plus 8, 2 4 is 8, e minus 2t, limit from 0 to 2. 2 minus 0 is 2, hence s is equals to 8 to the 16 plus 4, apply the limit e minus 2 into 2 minus e minus 2 into 0. So s is equals to 16 plus 4 e minus 4 minus e power 2 into 0 is e power 0. S is equals to 16 plus 4 can be write e power 4, e power 0 is 1, s is equals to 16 plus 4 upon e4 minus 4 ones are 4. 16 minus 4 is 12 plus 4 upon e power 4, which is equals to, take the help from the calculator, the answer is 12.1, correct to 3 significant figures. 12.1 meter. This is the answer of part B of question number 10. So hope you enjoy the whole question. Very important and very easy. Very important according to examination point of view. Move to last question of this exercise. Question number 11. Question number 11. A particle travels in a straight line so that t seconds after passing through a fixed point O, its speed v meters per second is given by v is equals to 2 cos t over 2 minus 1. Part A. Find the value of t when the particle first comes to instantaneous rest at the point P. So you know instantaneously at rest means the value of v should be 0. So 0 is equals to 2 cos t over 2 minus 1. Minus 1 shifted over left hand side, 1 is equals to 2 cos t over 2. 2 must be divided, so it is 1 upon 2 cos t upon 2. T upon 2 is equals to cos inverse 1 upon 2. Your calculator must be in radian mode. Cos inverse 1 upon 2 gives you pi by 3. Or t is equals to 2 shifted over there, it is 2 pi by 3. So when the particle is instantaneously at rest, the value of t is 2 pi by 3. Now move to part B. Find the total distance travel from 0 to t is equals to 0 to 2 is t is equals to 2 pi. So we have value of v 2 cos t over 2 minus 1. So first, before I apply the limit and I give you the concept of which is the limit of t, first we have to integrate v dt, which will gives us the distance. So 2 cos t over 2 minus 1 dt. S is equals to 2 cos t upon 2 integration is sin t upon 2 upon the derivative of t upon 2, which is 1 upon 2, minus 1 into dt is dt, dt integration is t, is equals to this 2 must multiply by 2, 2 to the 4 sin t upon 2 minus t. So this is the value of S. Now what is the requirement? Find the total distance from t is equals to 0 to t is equals to 2 pi. So because we have already the value of t 2 pi by 3 when the particle is instantaneously at rest, so we must find this distance from t is equals to 0 to t is equals to 2 pi by 3 and t is equals to 2 pi by 3, sorry, t is equals to t is equals to 2 pi by 3 to t is equals to 2 pi. But one point is very important, because we have already integrate. Our answer is 4 sine t upon 2 minus t. So first write 4 sine t upon 2 minus t, limit from 0 to 2 pi by 3, plus 4 sine t by 2 minus t, limit 2 pi by 3 to 2 pi. Okay. Apply the limit 4 sine t upon 2. It is 2 pi by 3, and this 2 must multiply by 3. It is 6. Minus the lower limit. The lower limit is sine t by 2. 0 by 2 is 0. The work has finished. Minus t. Apply the limit on t. 2 pi by 3 minus 0. So this is the limit from 0 to 2 pi by 3. Now plus I am applying modulus sign again. Why? What is the reason? Kindly wait. 4 into sine 2 pi. Upper limit is 2 pi and upon 2 is already present, minus sine lower limit. The lower limit is 2 pi by 3 and 2 is already present, so it is 2 pi by 6, minus apply the limit on t, which is equals to 2 pi minus 2 pi by 3, and apply the modulus sign. Now start simplification. 4, 2 3 is 6. Sine pi by 3 is root 3 upon 2. Minus sine 0 is 0, so no need to write 0 over here. Minus 2 pi by 3 plus 4. Apply the modulus sign again. 4, 2 cancel by 2. Sine 0. Sine 0 is 0. You can check from your calculator. 2 3 is 6. Sine pi by 3. Sine pi by 3 is root 3 upon 2. Minus 2 pi minus 2 pi by 3. 3 2s are 6. 6 minus 2 is 4 pi by 3. Apply the modulus sign. Two 2s are 4. 2 root 3 minus 2 pi by 3. Plus apply the modulus sign. 2 2s are 4 minus 2 root 3 minus 4 pi by 3. Now student, if I draw the graph of sine function from 0 to 2 pi, from 0 to 2 pi, I am just giving you some explanation. This is 0, this is pi by 2, because the maximum value of sine is 1. This is 2 pi by 3, this is pi, and this point is 2 pi. Now we have to find the area, because the distance means area under the curve. From 0 to 2 pi by 3, 0 to 2 pi by 3, 0 to 2 pi by 3, this is the distance. And from 2 pi by 3 to 2 pi, this rate region is below the x-axis. Therefore we must apply the modulus sign on the answer of below the x-axis. So our this value which we obtained from the limit 2 pi by 3 to 2 pi, we must apply the positive sign. What I mean, 2 pi 2 root 3 minus 2 pi by 3, this minus 2 root 3 becomes plus 2 root 3, and this minus 4 pi by 3 becomes plus 4 pi by 3, because this region is below the x-axis. So if the region below the x-axis, we apply modulus sign. Now you fully understand why we apply why I applied modulus sign, because we must convert all negative values into positive values. Hence our final answer is 2 root 3 plus 2 root 3 is 4 root 3. 4 pi by 3 minus 2 pi by 3 is 2 pi by 3. And this is the answer in your book. 4 root 3 plus 2 pi by 3. Or you can write the answer in decimal form, but because this is not the requirement, so I left it in root form or in rational form. So student, this is our today's class, where we did 2 questions from exercise 6.2 and successfully finished the whole exercise, and good news for you, the whole chapter 16. This chapter was very lengthy because all problems are word problems. There are so many parts in each and every question. 16.2, 16.1, though only 2 exercises are in this chapter, but all exercises and all questions are very important. What next? So how many chapters are left in our course? Only 3 chapters. Chapter number 5, chapter number 10, permutation and combination, chapter number 13, vectors. So out of 16 chapters, we have successfully finished 13 chapters. All exercises, all questions, all parts. So I decide to start chapter number 10, that is permutation and combination. I can show you. Chapter number 10. Yes, permutations and combinations. There are 3 beautiful brushes on starting page of chapter number 10. How many exercises? 10.1, 10.2, 10.3, 10.4. Yes, so only 4 exercises in this chapter. I promise you I will do each and every exercise and each and every question. So our next lecture will be consist on chapter number 10, exercise 10.1. So kindly be ready. One more request to all of you, kindly do subscribe my channel, and whenever you subscribe, don't forget to press the bell icon button so that when I upload my videos you will get the notification. Kindly share my videos to all of your friends, all of your class fellows, and each and everyone. Thank you, students. Good luck for next lecture.